Alright, and here we are with solving quadratics by factoring. Ladies and gentlemen, if you're in my Math 092 class, you have reached the end! It is the last video in our series. And it is with me, of course, Mr. Hain. Let me try to contain your excitement. Alright, the essential question is, how does factoring quadratics help solve them? Okay, let's dive right in. All right, so the zero product rule, which I affectionately call the zipper. All right, here we go. So what does the zero product rule mean? It means, as if we're looking at example number 1, it means that if A times B equals 0, then either A or B have to equal 0. What that means is if I'm looking at example 1 right here, I see that I have 3x minus 1. This is a quantity. This is like A. Times x plus 2. That is a quantity like B. If I am multiplying them together and I have an equal 0, then what I can do is actually split them up and have them both equal 0. This gives me the solution to this quadratic, or solutions to this quadratic equation. So looking at the first one, 3x minus 1 equals 0, I just add 1 to each side, kaboom, 3x equals 1. Then divide each side by 3, and I know that x is equal to 1/3. But wait, there's more. I also have x plus 2 equals 0. This means that if I subtract 2 from each side, I have x is equal to negative 2. What this means is I have two solutions to this quadratic equation. Boom. X equals negative 2 or 1/3. And that is my answer. Go ahead and pause the video and check out checkpoint 1. That was not on purpose, but check out checkpoint 1. Do it the exact same way using the zero product rule. Pull that zipper, find the solution. It's like a Christmas gift. It's right there. Let's go. Pause the video. I'll be here when you get back. All right, we got some more examples. Okay, we're going to put it all together for example number 2. Okay, example number 2 is not factored. So a times c is negative 8. 2 times negative 4 is negative 8. There are two pairs of numbers that actually combine to multiply towards negative 8. And if I put them in the x, I know my b term is positive 7. So that means there's only one of these that actually adds up to 7 and multiplies to negative 8. And those numbers are negative 1 and 8. Kaboom! Let's put it in. Let's expand that middle term. So I have 2x squared minus x plus 8x minus 4 equals 0. Okay, I know I can factor these. So I'm going to group them. I have no third term negative, so I don't have to change any signs. And out of the first term, or first group, I can actually factor out an x. And out of the second group, I can factor out a 4. That gives me x times 2x minus 1 plus 4 times 2x minus 1. How do I know I'm on the right track? Because the binomial factor is identical. So 2x minus 1 gets factored to the front. I have 2x minus 1 times x plus 4 equals 0. Lo and behold, this is example 1. We know how to do this. We're just going to take them, we're going to split them, and then I'm going to go ahead and solve for one of those x terms. I'm going to take the next one and I'm going to split it off and I'm going to actually solve for that x term. I have two numbers, which is fine because the exponent says there could be 2, 1, or no solutions. I have 2. Kaboom! X is equal to negative 4 or 1/2. Woo! Whoa, that was a lot to unpack and that was a lot to hold on to. Really, all I'm doing is applying what we already know. In our previous video, we explored what it was like to factor quadratics that have a not equal to 1, just like here in example 2. After we factored it, all I'm adding is actually saying that the entire quadratic is equal to 0. This lets me solve for the two values of x that would make this equation equal 0. Kaboom. All right, let's dive into example 3, which looks a little bit different. What I'm going to do is I want this whole thing to equal 0. So I'm going to subtract the 2x. Why the 2x? Well, because it has the lower exponent. It has the lower degree. So I'm going to subtract it so it's on the same side, and I can factor. It's like my favorite math F word. I can factor out that x. Skadoosh. So now I have x times 3x minus 2 equals 0. This is the zero product rule. I pull the zipper on them to split them in half, and I've got x equals 0, that's easy, and then 3x minus 2 equals 0. Add 2 to each side, divide by 3, x is equal to 2/3. You guys know I could have had two answers. I do. My solution is x equals 0 or 2/3. All right. Go ahead and solve checkpoint 2. And this should be checkpoint 3, but we'll just call it checkpoint 4 for now. And pause the video. I'll be here when you get back. Kaboom! All right, so yeah, this is actually checkpoint 3 right here. Sorry guys, I pointed at my screen. I'm wiggling my mouse now. So the checkpoint 4 is over here. Okay, so let's solve these quadratics. Yeah, you don't like number 4 because it's not equal to 0. And in fact, it looks like the equal sign is misplaced in the middle of this quadratic. So what am I going to have to do? I'm going to have to move the 6x minus 9. So I'm going to subtract the 6x from both sides and add the 9 to both sides. The key thing is on the right-hand side of my equation, those cancel out. Kaboom. X squared minus 6x plus 9 equals 0. Yes! There it is. Okay. A times C is 9. I know they have to add up to negative 6. Positive 9, negative 6. The only numbers are two negative 3s. That's where it gets interesting because I have the same term, x minus 3 and x minus 3. And that's something interesting because I see that they are the same term. So that's x minus 3 is equal to 0. So I add 3 to each side, and there we go. X is equal to 3. Now remember what I said before. This squared term means that I could have 2, 1, or no solutions, which means I only have one solution this time because the same factor happened twice. All right. Let's take a look at example 5. You don't like it because the 16's on the wrong side. So I'm going to bring it on over to the right side, which is the left side. All right. So 9x squared minus 16. So this is weird because I realize that 9x squared and 16 are both perfect squares. This is a difference of squares. So if I remember my shortcuts correctly, I see it's 3x squared minus 4x squared. So that's 3x plus 4 times 3x minus 4. Sweet. So now that I have factored this, I can actually split them up using the zero product rule. So 3x plus 4 equals 0, subtract 4 and divide by 3. And 3x minus 4 equals 0. So I add 4 and divide by 3. Gives me two solutions. X is equal to negative 4/3 or positive 4/3. There we go. Okay, so go ahead and pause the video, do checkpoint 4 and checkpoint 5, and I'll be here when you get back. Example 6. Oh, this looks fun, except, hey, what the heck is this? The 6 hanging out over here. Man, come on now. This should be a 0. So what I got to do, I got seashell. So I'm going to multiply all of my terms times each other, and there we go. X squared plus 3x minus 2x minus 6 equals 6. Now I got to set the equation equal to 0. So I'm going to combine those two middle terms first. Positive 3x minus 2x is going to give me positive x. All right, move that x from the right to the left. That cancels on the right to 0. And of course, negative 6 minus 6 is negative 12. Say it with me. The same signs, add them up. All right, there you go. It's negative 12. And now it's equal to 0. So I use my x to factor, and the only two numbers that multiply to negative 12 but add up to positive 1 are negative 3 and 4. So I know that my factored form is x minus 3 times x plus 4 equals 0. Well, the only thing that would make x minus 3 equals 0 is if it was 3. 3 minus 3 equals 0. And the only thing that makes x plus 4 equals 0 is negative 4. Negative 4 plus 4 equals 0. So I know that my answer is x equals 3 or negative 4. And it's probably time for me to tell you that mathematicians prefer to write their answer sets from least to greatest, which is why I have x is equal to negative 4, 3. Awesome. Go ahead and solve checkpoint 6 the exact same way I solved example 6. Foil it out or seashell it out, however you would like. and move that 28 to the left-hand side and refactor that bad boy when it's equal to 0. I've got faith. Pause the video. I'll be here when you get back. What? There are words? Who put words into math? All right, here we go. Example 7. Let's apply some quadratic equations. So the formula h is equal to negative 16t squared plus 48t plus 160 describes the motion of a ball thrown straight up from a rooftop 160 feet high. Why is someone standing on top of a 16-story building throwing a ball? Only in math, people. Determine how long it will take for the ball to hit the ground. We actually got this. This is awesome. Okay, the ground is 0. Like, it's 0 feet. So the h here is height for my formula. So I can actually say equals 0. Awesome. Now that is a nasty looking quadratic until I realize, hey, I can factor out a 16. So if I look at the quantity, I have t squared minus 3t minus 10. I can factor that. Let's see. Multiplies to negative 10, adds up to negative 3. 5 and 2. And 5 has to be negative. So now I've got t minus 5 and t plus 2. Okay, cool. Because see, the t minus 5 part, I know that it has to equal 5. But the t plus 2 part means that I get negative 2 seconds. If you can give me negative 2 seconds, then you are Doc Brown and we are in Back to the Future. And I'm not thinking fourth dimensionally, Marty, but we have no negative seconds. So we reject the second answer completely. So t is equal to 5. Kaboom! 5 seconds for that ball to hit the ground. You can now solve math problems that have that many words in them. Well, I mean, you could before, but now you can solve those kind of problems. All right, so go ahead and try checkpoint 7. You might have to move some stuff around because you want it to equal 0, but I know you've got it. Pause the video. I'll be here when you get back. Did you see the t equals 5 seconds just pop out of nowhere? Sweet. Till next time, people, keep doing the math.